There are many ways of approaching breast imaging, and because there's so many technologies, people get confused.
This is going to come up one more time, okay?
The standard screening method for women is the X-ray imaging of the breast, or mammography. Mammography is fantastic at identifying little tiny white dots on a mammogram, which represent calcifications, the earliest stage of breast cancer. A weakness of mammography would be in the setting of a woman who has very dense breast tissue. And that's because dense-breasted women have mammograms that are almost entirely white. And so cancer, which is also often seen as a white abnormality, is harder to detect. That said, it is still a very good test for screening all women and has been shown to reduce mortality from breast cancer.
Another way of looking for breast cancer is with breast ultrasound. Although mammography can find many breast cancers, sometimes ultrasound actually will find others. The problem is that it will miss those little calcium particles. Now there's other ways of looking at the breast besides mammography and ultrasound. One is MRI. And MRI uses strong magnets to look through the breast tissue, and they give contrast in the arm. And what happens is that those cancers will light up bright, and so it will show us little cancers that can't be seen any other way. But I ought to say, you can't just get the MRI. And the reason is because it will miss the earliest form of breast cancer shown by mammography and calcifications.
We'll take this lateral picture.
There's a new technology called 3D mammography, or also called tomosynthesis, and it's something that we've just recently started offering at Stanford.
Take in a breath and hold it.
In the early clinical trials, the data has shown that this new technology decreases false positives and increases cancer detection, regardless of a woman's breast density.
The way that you take tomosynthesis is the breast is compressed, and then you have extra pictures taken like this. The images will produce little areas of pictures through the breast so that we can see every little bit of it. And it's been shown in studies that tomosynthesis can increase the detection of breast cancer by about 25 to 27%. That's huge. Plus, it decreases the number of false positives between 15 and 17%.
Recommendations for screening are generally based on a woman's risk for breast cancer. Various factors play into a woman's risk for breast cancer, including her age, her family history of breast cancer, family history of ovarian cancer, her breast density, and then any genetic predisposition to breast cancer, such as a BRCA mutation.
At Stanford, we're going to use all of our technology, all of our research, all of our experience to try and do our very best for every woman to find breast cancer early and cure it.